We have developed an ultrasound simulator that uses virtual objects embedded in an ultrasound phantom. Cross sections are generated on the fly using a simulated ultrasound probe that is tracked in space with 6 degrees of freedom. The objects used in the ultrasound simulator are simple, recognizable shapes. We purposely left out anatomy so that learners can focus on cross-sectional literacy of familiar objects without having the additional burden of learning anatomy. There are 4 types of exercises in the ultrasound cross-sectional trainer: reading cross-sections, obtaining desired cross-sections, interpreting cross-sections, and finally needling and intervention. The reading exercises places single shapes for the user to scan. When the user is ready, they are presented a multiple choice question and choose the correct picture of shape from a list of objects. Objects increase in complexity and require additional probe manipulations for correct identification. In this problem, the user must apply considerable tilt to the probe and slice a pyramid-like shape from the side so that the number of sides may be counted. Obtaining desired cross-sections is the next task. The user is presented with a cross-section that must be acquired by manipulating the ultrasound probe. Successive problems may require specific probe manipulations. Here, the only solution to get a square cross-section level, as requested, is to apply rock or toe end to the probe. Users can practice rotating the probe while maintaining a target in the center. Some of the problems are inspired from Santa Barbara Solids test. The simulator has the potential to add a psychomotor component. In this problem, the user is asked to place the probe to obtain a specified cross-section. How long will it take you to obtain a perfect hexagon from a cube? In the interpretation problem group, emphasis is first placed on sightedness. Users are first tasked with identifying a set of tubes in order. The problems are structured so that the alignment of the probe to the dot marker on the ultrasound screen must be considered. A cognitive aid that defines probe alignment can be used to specifically place the probe. Here, the user is holding the probe with the notch in the 3 o'clock position. Other tasks include tracing structures as they wind around other similar structures and planning out the safest needling areas. The simulator includes a needle that is tracked in 3-dimensional space, which is in the same manner as the simulated ultrasound probe. Additionally, the needle is rendered in the ultrasound image. Therefore, in-plane and out-of-plane exercises can be practiced and demonstrated by the software. Additionally, needle anisotropy and unfavorable angle of incidence can be simulated if desired. An incidentating plane view of the needle can also be shown. This enables the user to see why they may not see the needle, or if what appears to be the tip is really the shaft. Needling exercises increase in complexity. In this exercise, a small vessel must be accessed while avoiding a nearby large vessel. Physical objects in the gel may be used as bones to provide obstacles for the user. In the most difficult cases, bones cast shadows in ultrasound and make approaches to virtual vessels challenging.